Amazing. Hello everyone. Today I'm happy to talk about Ceph management with openMedic. Let's start what I want to talk about today. First of all, the different components. So Ceph in general, I hope everyone is aware of what Ceph is. Can you maybe raise your hand if you've never heard about it and have no clue what it is? Joao, that's a lie. My macro is turned on, yeah, should be, so of course. Second thing, Salt and Deepsea, openMedic in general, and then Prometheus and Grafana. Yep, come in, please. Let's start with Ceph in general. What is Ceph? Just a quick introduction. Maybe there are some folks who've never heard about it. Ceph is a distributed object storage. The cool thing is it not only supports objects, as it's part of its name, it also supports block and file storage. So you can say maybe it's the unified storage because it combines all the different storage layers. Ceph per se is designed for scalability and reliability in general, and of course this is a thing of definition, performance. Ceph motivation principles. Why was Ceph initially started, or what are the ideas behind the development? Ceph is a totally scale-out system, so it scales horizontally up to thousands of storage nodes. You can combine them into one big cluster. It was from the beginning designed to have no single point of failure. This is really important. This is a key differentiator to other storage solutions. It runs, of course, on top of commodity hardware because you just need a standard Linux, doesn't matter, and on top just install the Ceph packages. So you could use your hardware you usually use. It is self-managed and self-healing whenever it's possible. So there are lots of mechanisms included into Ceph which makes sure that the Ceph cluster is always up and running and in a consistent state. And of course, it's completely open source. Those are the components of Ceph, so the different ways how to get access to the data. First of all, underneath there is the Rados layer here. This is the distributed object storage underneath, and then you have 4 different ways to access this data. First of all, there's libRados directly, so you can query libRados via your preferred programming language. Just to mention a few: C, C++, Java, Python, whatever, feel free to use. Then there is the Rados gateway. This is a REST gateway compatible to S3 and Swift. Lots of the time used with OpenStack. I guess you already heard in other talks yesterday and today. Then we have RBD, the Rados block device. Those are mainly used for virtual machines to directly add physical storage to the virtual machine. And last but not least, CephFS, so the file system from Ceph on top. Those are the different ways how to get data out of your distributed Ceph storage. Salt, that's another key component. I think almost everyone knows what Salt is. If you've ever heard about Puppet, Ceph, Ansible, all the deployment tools, Salt is yet another deployment tool, of course. But what were the reason why we have chosen Salt and not one of the other existing tools? The answer is quite easy. Salt is really scalable up to those many nodes. I see your face, Owen. Up to a few thousands of nodes. What's really nifty is the parallel execution included in Salt. So if you run a command on your client, so-called minions, this is executed in parallel. So this makes it, on the other hand, really fast, and it has its own protocol. So there is no initial SSH connection needed to get things done. So this makes it really fast. As usual, it's easy to get started. I guess everyone tells you that his thing is easy to get started with. I think Salt is, because you just have to write some YAML files, so that's doable, I guess, for almost everyone. And it has a really active community, so feel free to contribute. What we made with Salt is something that's called Deepsea. That could be a little bit weird. What is Deepsea? Deepsea is just a tool that uses Salt and combines Salt to be able to manage and orchestrate almost the whole Ceph cluster. From the initial deployment to upgrades to adding nodes, deleting OSDs, all the kind of stuff. That's included into Deepsea, and it uses Salt at the end. Right now, Deepsea supports those kind of features. First of all, I already mentioned the initial deployment configuration. Then something that we call engulf. This is the initial support to import older Ceph clusters or Ceph cluster you deployed, for example, with Ceph deploy. So if you have in the past in your environment deployed a cluster with Ceph deploy, you can migrate it on the fly with Deepsea to Deepsea. Then Deepsea is able to deploy the Rados gateway for single-site deployments, where it's also possible to deploy the CephFS MDS. Then we can create and also create the shares for CephFS and S3 for NFS Ganesha. This is possible with Deepsea, and there are some more features. We're able to deploy iSCSI targets and as well as the iSCSI gateways. Right now with LRBD, in the future with TCMU Runner, this is right now under heavy development. Then we also deploy the Grafana and the Prometheus node we're using to monitor our cluster environment, to gather the data and to visualize it at the end. And the interesting thing, and also one part of the topic of this presentation today, it can also deploy and do the initial configuration of openATTIC. Let's talk about openATTIC. openATTIC is an open source management and monitoring UI for Ceph. In the past it was a little bit more, but I will talk about this in 1 minute. The idea behind openATTIC when we initially started was we want to build up a web UI tool that an admin would like to use, because most of the time there are several UIs out there. They're really cool, but at the end you're still using the CLI because it's more powerful, it's faster, and in general you have lots of folks who just don't like UIs in general. So we had in mind we want to build something that is usable for administrators as well. A really important thing was to build openATTIC as well. I would say kind of stateless, so that those administrators who are, want to manage their cluster with the CLI, with different tools, with different REST APIs, doesn't matter, can still do that without the need to have caching and all the kind of stuff, which is sometimes really annoying to do that. Just look in the past for those who have seen or know about openATTIC from last year or did not follow the whole development this year. What we had with 2.x already was Ceph cluster and status dashboards. Those were based on still on Nagios, gathering the data with Nagios and Isinga. We had initial pool management and also pool monitoring, also based on Nagios. We were already able to manage, delete, create new RBDs. We could monitoring them. We had the view of cluster nodes and roles. There was just a list with the node name underneath, so you were aware how many nodes are part of my cluster, but there was no interaction with it, so no further commands. It was just a view only. And the support for multiple Ceph clusters. So if you had, for example, a development cluster and a productive cluster, you could just put them both underneath the same UI and manage them within one centralized UI. Notable changes in 3.x, I guess that's really, that was a big step forward. We refactored the whole code base. As I mentioned before, with 2.x, it still was possible to also manage local storage. That means from initially openMedic was built to be a local storage UI to set up LVM, NFS shares off top, iSCSI, all the kind of things. And we removed all of this code within the 3.x release and the new branches, and we refactored so it now supports Ceph only. There's no traditional support anymore. As I mentioned earlier, it's now completely stateless. You can just spin it up, do changes somewhere else, doesn't matter. openATTIC will instantly recognize because it will just gather the data live from the cluster. From a developer perspective, we a little bit simplified installation. We now have just a single package and not a UI and a backend package anymore. We removed a lot of dependencies because we removed the traditional stuff, and now we don't need all the LVM and all the other stuff, so we removed all the packages. Really important thing and already noticeable on the web UI is that we removed the monitoring, so Nagios and Deepsea with PNP for Nagios with something more, I would say 2000 and now it's 18. So we replaced it with Prometheus and Grafana. And we also added a bunch of more things like notification, more robust error handling. Yeah, I will show you later in the live demo. I guess this is, yeah, makes more sense. New features we added to 3.x. We not only refactored the whole code base, we added new dashboards based on the new monitoring system we added. So we added dashboards from Grafana directly. We're getting the data with Prometheus, and then we added the Grafana dashboards into the UI, including them. We're now able to manage the Ceph object gateway within the UI. We can manage iSCSI targets in the UI via LRBD to create new iSCSI targets, add initiator, add authentication rules, whatever you want. We can create NFS shares with NFS Ganesha also within the UI. So there's no need to go to CLI anymore. And really important, we support the newest release, the newest stable release, Luminous. And also with some Luminous features, for example, they were introduced with Luminous, such as pool compression. That's also possible to set within the UI. Last but not least, we improved a little bit the pool management or RBD management. We add more capabilities. We can now set cluster-wide OSD flags. I will show you later. And with Prometheus, we are now able to do node monitoring as well. So we not only gather the data from our Ceph clusters and the pools and the OSDs, we also gather the data from the nodes itself. So CPU, memory, network bandwidth, all the kind of stuff. And you're able to view this in the UI as well. While I already talked about Prometheus and Grafana, let me just tell you just a little bit about what it is. I guess you already heard. I know they have a separate booth and there's separate presentations about it, but just to wrap up, Prometheus is a time series database. It collects all the data via its node exporter, for example, or Ceph exporter, and gather the data. And then we have it in one time series database, which is quite nice, but the user expects something more visible. So we are using Grafana. So we're adding Prometheus as a source to Grafana to visualize those data within graphs to make it more, yeah, I would say human consumption, to make it, I would say, pretty. Those dashboards, as I mentioned already, are exposed via the openATTIC dashboard, but this is really important. The standalone dashboards are still accessible. So if you decide to create your own dashboards, or you want to use this overall Grafana instance for your whole environment, and you just want to have one instead of several dedicated Grafana instances, you can do that. So this is no encapsulating, something like that. It's just a default Grafana instance, and we are embedding those graphs. And if you want to change something of the defaults, feel free to do that. There's Grafana still reachable on port 3000. Just connect to it and modify your Grafana. Same Same thing for Prometheus as well. Just a little bit about the architecture, how it looks like. From a web UI perspective, if a user opens the web UI, it directly talks to the openATTIC backend. This is completely written in Python. And then we have different ways to get the data out of the Ceph cluster. First of all, you have seen in the Ceph stack at the beginning, we are using liberators to gather some data from Ceph directly. Then we are asking Ceph Object Gateway as well. Then the important part for deployment, and right now for the iSCSI management and NFS management, we are querying the Salt REST API. We're querying, at the end, we're using Deepsea, so we're querying the Salt API, and the Salt API triggers Deepsea to gather the data and to give us the data back. And then to show nice, shiny, fancy graphs, we're using Grafana embedded into our UI. Yeah, come on in. Just a short outlook. I tried to keep those slides as I don't want to rush through, but I think everyone is more interested in a live demo instead of slides because I've written it down in the presentation description. So I will keep this as short as possible. Just the outlook, and I'm really happy to do that because it's awesome, right? This is the openATTIC login screen. This has a cool logo, and there's a logging thing. It's nice, and it's a little bit of black. That's cool. But this wasn't the outlook. The outlook is more like this. But now is the question, what really changed? Where is openATTIC? Yeah, you're right. We replaced the logo. Now we're using the upstream Ceph logo, which is kind of cool. That's obviously openATTIC 4.0. We released it with this new cool logo. No, just kidding. There's a lot of more behind. Why we're using this logo and why we replaced the word openATTIC completely with Ceph is, and I'm really happy to announce this, is that the idea is to get openATTIC upstream, directly openATTIC upstream. The idea behind is to replace the existing manager dashboard with openATTIC. At the end, it's a Ceph dashboard. There is no mention of openATTIC, the name anymore. Of course, it's still in the code, but it will go away. We will try to push all of that. We're right now refactoring it into Ceph Manager as the default dashboard. We made this decision, I think, 2 or 3 weeks ago, so this is brand new, and feel free to spread this around the world. If you're interested on what we are currently working on, right now we're developing the initial pull request in our own GitHub repo, and the idea is as soon as we have something that is compatible, we will push it upstream. That's the idea behind it. So in the future, there's no standalone openATTIC more. It's just its default part of Ceph. So as I promised at the beginning, I have a live demo, and I hope this Wi-Fi is better as it was the whole week. Let's give it a try. What's cool is that I have to look here and scroll here. That's really nice. No mirror screen. Let's see if this is working. Nice. The Wi-Fi is awesome. I do it this. So I skipped the login screen. I know it's awesome, but I skipped it. I'm already logged in. Everyone can take a look at this. There's also a live demo on demo.openattic.org, so you can, if you want to play with it, feel free to do it. It will be resetted every day at midnight, so if it's broken or not reachable for a few hours, then someone did something stupid, and then it will be there next day again. This is the landing page. This is the Grafana, the initial Grafana dashboard I was talking about. So what we did was we embedded the default, as you can see, the default Grafana dashboards into our UI to use it from there. There you get a quick overview about the status of your current cluster, the health status, how many pools do you have, about the size you used. Within that, you have all the cool Grafana features, this overlaying. You can zoom in directly. All the graphs will update automatically to this timestamp you have chosen. So this is really cool. Then we added not just this single dashboard. Those are the default dashboards from our end. But as I mentioned, if you need more, just add them within the Grafana UI. Just one thing to mention, name them differently, because if you name them the same way that we did, you do an upgrade right now, it will just overwrite your files. So just name it differently. Maybe to mention, because I put it on the slide, is the node statistics. We're gathering now CPU, memory, all the data, and visualize them from every node that's part of the cluster. If this would have been physical hardware, we would get those data as well, but those are virtual machines on hosted, so there is no smart data. You can switch between different nodes. This cluster is a cluster out of 7 nodes, so if I'm interested in this node, just click on it, you get directly the information from this node. Same thing, I'm not quite sure I want to show all of the dash, just a few. For OSD, for example, so if you're interested in a specific OSD utilization, how many PGs are stored there, you're gathering the data and visualize it here. Let's go to the OSD tab. This cluster is really big. It has, in sum, 6 OSDs, which is amazing. If you click on OSD, it will automatically show you the graph you've seen on the initial dashboard as well. So we embedded those pool OSDs, node graphs on those tabs as well. So there's no need to go to the initial dashboard, but you could if you want to. One thing that's really new is the configure cluster-wide OSD flags. So within the UI, you can now set flags like you can pause the cluster, of course, which makes inaccessible anymore. You can send no scrub all the things you're usually using within the UI. That's now possible within OpenMedic. From the RBDs tab, same here. You get some initial information about the RBDs. Then the statistics is again the Grafana dashboards, and there are no statistics. That's cool. We can add new just to show you the dialog, what we are able to do. You can give it a name, say, okay, which pool it should belong to. That doesn't make sense. You can give it a size. You can use the default features or adapt the features to your need. We also try to add a few hints and try to combine those features, because there are several features that belong to each other, and it's not possible to set a feature without setting the other feature beforehand. So we try to visualize this within the UI. So as soon as you click a feature, all the other features that are not possible right now are grayed out, and vice versa. Yeah, this is one of the hints we've added. For example, you have done something, and now it reminds you really want to leave the page because you did not click create or what else. This is the pool. Looks quite similar with details of the pools. You also get, again, the statistics, so the dashboard of those pools. There they are. There should be more. Yep, here it is. There's more. The resolution of this beamer is awesome. Just to show you here what's possible to do. You can say, okay, I want to replicate it, or an erasure-coded pool, for example. If you click on replicate it, you get those various variables you can configure. Same for erasure-coded. It will instantly update the fields, and then you can say, okay, what do I want? I want compression. Now you have to select an application on top. You have to select You have to select what do you want to use the pool for example, for CephFS or RBD. That's all possible within the UI. And I guess this is a link to upstream. If you have a problem to calculate the placement groups, which could be sometimes a little bit difficult, there's a direct link to upstream with the formula how to do it, to calculate what's best for your specific pool. We improved the Nodes tab a little bit. In the last version, we just had shown the host name, and that's it. Now we also show cluster, the roles. Those are assigned to those nodes. So for example, this one is our master, administrator, and openATTIC node. This is monitoring node, manager, and storage. Or this is an IGW for iSCSI gateway and also storage node, for example. Same here. If you click on statistics, you get the statistics for this specific nodes. And you can also trigger a task. We included scrub and deep scrub. So with the UI or within the UI, you can click and say, OK, I need to scrub this node. iSCSI. That's one of the new features we've added in the back end, powered by Deepsea. We're using Deepsea. Within iSCSI and NFS, we also added the managed service dialog, so you can stop and start the iSCSI and the NFS Ganesha services, or at least restart if you have to. And just to show you what we've added, first of all, of course, an iSCSI share needs a name. You have to specify the portal. As in this cluster, I only deployed one iSCSI gateway, so I can only select this one single node. I can add, for example, an image, it's a demo image, and then we added authentication as well. Default is just user password and the initiator list, but we also added mutual authentication and discovery authentication, and you can combine them as well if you want. I know it's sometimes kind of hard to do that. I usually just stick to user password, but maybe some of you using, for example, I don't know, mutual authentication, so you can still do that. Same for more or less NFS. There should, in a few seconds, appear right here also the managed service. So there we can also start and stop the NFS service if we have to. We get those. What's really nifty, we added, for example, those little hints. So how do you mount this share to a specific client? If you have no idea how to do that, just copy and paste this command to your client, and that's it. So we try to improve the usability over time, and there's lots of things we have to improve, but I think we made a good step forward. Let me just edit an existing share to show you what's possible to do. Just 5 more minutes, Wi-Fi, please.
You actually have 10.
I have 10. Amazing. Then I can just reset. Yeah, there should be an added dialog of NFS. I think everyone can imagine. Yeah, you have a question. Sure.
While it's loading, I guess.
Yeah, sure.
If you can talk a bit more about like failure scenarios and if it can react, like do things automatically for failures, or
Okay.
you have to actually see your work and do something yourself.
Okay. The question was if we can do something interactively with failures. So, for example, if this crash or something automatically, if something happens to the cluster, if we can trigger something. No, that's not part of the web UI so far, or not part of the core. You get just notified that there's something wrong, and then you have to do something. Couldn't load NFS export. Oh no, it's done something. That's amazing. Let's click here. So no, right now this is not automatically possible, but I guess that's something for the future. That's really cool. I don't know why. Let's click on add. I don't trust this Wi-Fi here.
You shouldn't.
And I don't. I don't know, 10 more. How many clients are connected to it? I don't know.
I can set up a hotspot in my phone if you want.
Or I skip the NFS part. If it's not. Can try to let it go. Yeah, why so let's give it a try. If I don't know if it's general Wi-Fi problem or problem of this instance. Or someone of you, while I was talking, connected to the live demo, right? And did something. Evil you. Should not mention. That's the reason why I'm in full screen. Oh no. Object gateway. So we are now able to manage the users of the gateways as well. So create new users and adapt quota, for example. Initially, you get those details listed here. Then we also have statistics again. I hope this is working better. Yeah, of course. You can create your users, add, for example, sub-users for Swift. You can add the keys you need and you want to. You can adapt the capabilities of this user. For example, a user should just read, for example. You can just adapt those. You can set user quota, and interesting, you can limit it by size or by amount of objects, and the same for the bucket. So you can also limit, I'm not quite sure if you're able to see this because of the hats, by also size and quota if you want to. A really cool and amazing thing is still the crush map we've visualized within the UI. It's just a visualization of the crush map. You can't do anything with it. It's just a view only. In 2.x we had a editable crush map thingy included, but yeah, after we figured out that it's so easy, we implemented that you were able to just drag and drop, for example, your rack or your nodes within the tree and click on save here. I think this is a great idea. I want to reorder my whole crush map. And we figured out maybe to prevent the user, this is not the best idea to let them play with. We need something more guided, like a wizard, to create a crush map or to change something within the crush map. So we decided we want to remove the edit feature for now and edit later, again, as soon as we have something that is more major than just a drag and drop virtual tree. But it is still there, but I think I'm definitely sure it will go away more or less with Ceph Upstream. Users is unspectacular. I guess a cool thing also is the settings page we added to the new version. It's now possible to specify, for example, the Deepsea host, the Grafana host, or the object gateway host within the UI. You don't have to go to the CLI and configure the IP addresses, passwords, whatever, shared secret there. This could be done within the UI. This, for example, this cluster was spinned up with Deepsea completely, so those details are automatically added with Deepsea if you deploy it with Deepsea. That's what I mentioned, that Deepsea is capable of deploying openATTIC and do the initial configuration. So we have the same for object. Here's for Grafana. So if you have a, I don't know, dedicated Grafana instance in your environment somewhere else, sure, why not use it? And last but not least, the path to the keyring and the user behind. What is always really helpful for us is this little thing. I just want to mention it because it's not used that often. Report a bug. So if you found something, don't just close the software and run away. It would be really helpful to let us know that you found something, or you had problems, or the documentation is totally horrible, or the whole thing is total crap. Then we want to hear why. That would be really important to us. It's not, on the one hand, it's really cool if you say this is really helpful, but what is even more helpful is to know what is not perfect, what is missing, and what features are not working currently. One thing before we go to question and answer is the API recorder. I just want to show you. You can click on the API report. I hope we can give it a try. I'm not quite sure if this really, this is not a big cluster, and I hope it will survive. I will show you the API recorder. this is something for those folks who don't like to read the documentation in general. How many space do I have? I guess 1 gig is sufficient, right? Blah, 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 doesn't matter. Yep, there it is. And now you can click stop. And the cool thing is, now you get, more or less, I would say, up and running Python script out of it with the calls that we did. So that's exactly what we did. We're calling our own REST API within the UI, so this is what we did. So you can adapt those settings and use the script to, for example, create new RBD devices. And so there's no need to read the whole documentation because most of the time I don't like documentation. So as we have just 5 minutes left, I would switch really quickly to question and answer. Yes, sir.
So, sir, thank you. You gave this really nice talk at the beginning about how Ceph is highly available and all of this stuff and has no single point of failure, which I agree with. But doesn't Salt itself have a single point of failure and that you have that central orchestrated you
Yeah.
go through?
Yeah.
Is it incompatible? You have one that is, but then you're stuck with
And at this point, you're definitely right. You have a problem with the single management system. You can make it more or less high available with, for example, syncing the data and do a pacemaker cluster behind for the management thing. But at the end, this wouldn't influence the accessibility of your data because if the management node is down or corrupt in any case, doesn't matter. Your clients can still access the data. This is completely independent of the deployed cluster. But yes, in this case, you're totally right. This is exactly what we are currently working on.
I mean, if you have a failure in your infrastructure,
Yeah.
it possibly affects your management thing and your Ceph thing.
Exactly.
Can you fix it and
So
what would your plan be if I wanted that as a customer?
yeah, the idea behind or the outlook for the future is to have this all based in the core. So that is part of the cluster to do the deployment. But for now, we have to stick with what we have, and this is from our end Deepsea, and upstream users, most of the time I guess Ceph Ansible.
If the Salt master goes out, you still manually fix your Ceph if you need to.
Yeah, sure, doesn't matter. So that's what I mentioned. We are using Deepsea to deploy the cluster is just for deployment, and also you can use it for orchestration. But if there's something broken within this master management system, doesn't matter. You can manually fix your cluster. You can still access the web UI, for example. You can just spin up a new web UI because it's stateless. This will directly gather the data. So yeah, it would be. It's in this case a single point, but it doesn't affect your clients or your data. Yes.
So it's a question about how opinionated the openATTIC is. We're running, for instance, Ceph using the Ceph Docker project.
Mm-hmm.
So we're running Ceph with Docker, and we deploy it ourselves using Chef.
Mm-hmm.
And we have our stats in OpenTSDB and display them in Grafana as well. So how well would openATTIC play with that scenario?
Generally speaking, out of the box, with Grafana wouldn't be a problem. We can still show all the data within the UI. The only thing that would be missing is the iSCSI NFS management part, because therefore we need Deepsea right now. So this part would be not usable within the UI.
All right.
But the rest is fine. And the idea or the plan behind why we're moving upstream is to remove this dependency as well, to be completely independent at the end and not rely on, I don't know, a specific deployment tool to remove exactly this behavior.
Right.
Another question, I'm not quite sure, I have 1 minute left or?
1 minute.
1 minute. Yep.
On the OSD display, how does it scale if you've got hundreds of
Hey.
elements there?
That's not,
Filtering and searching.
on this page, it's not a problem because we do pagination. So we gather the data and then we have this pagination here from, by default it's 10, but can scale up to 100, for example. But you're right, and we already replaced this, just to mention it. For example,